Next, we will be demonstrating the charging rate of the motor by feeding the output of coil pod 2 into a 400 volt DC capacitor. The rate at which the motor is charging can be identified by the multimeter connected directly to the capacitor. Every test we have run, like the one you are about to see, was approximately 2 minutes long, bringing the capacitor up to 80 volts. As you can see by the video, the capacitor has been completely discharged. The white wire you see is the connection that will be coming from coil pod output 2. The yellow connection is still feeding our charge battery. Now we will bring the motor up one pod at a time. The blinking light you see there on pod 2 is an indicator that the output power is not being harvested. Now we will make a connection of output from coil pod 2. As you can see, the capacitor begins to quickly fill. The multimeter was set at 20 volts for reading the battery. We are now setting it at 1000 volts DC, and the capacitor continues to fill. Our charge battery is still maintaining 12.56 volts, and our run battery 12.21 volts. The current draw from the motor to the run battery is 0.48 milliamps. This type of test provides you a clear understanding of how quickly the power freedom motor can charge a bank of batteries. Because it is a pulsing output power, you must connect the output power to either a capacitor or a battery in order to smooth out the power wave. Once the capacitor has reached 80 volts, we will stop the motor and discharge the capacitor. As you can see, the multimeter is slowly discharging. Rather, the capacitor is slowly discharging. That is because the indicator light for pod 2 is holding at a steady stream. It is burning off the excess output power. By using a standard 120 volt light connected to each end of the capacitor, we can quickly discharge the capacitor safely. As you can see, the capacitor has been discharged . And once again, you can clearly see how fast the power freedom motor can charge the capacitor. Keep in mind that this particular demonstration motor is providing one level of power generation. By increasing the number of coil pods, you can increase the number of power outputs. Additionally, increasing the coil size and/or the input voltage will also increase the output capabilities of the power freedom motor. This reflects the scalability potential of this motor.